We're counting down the 7 most colossal trains ever built, locomotives so massive their weight threatened to overwhelm the very tracks beneath them. From modern engineering marvels that pushed the limits of technology to historic steam giants that made the rails tremble, each entry reveals new extremes in size, power, and impact. Which machine nearly broke the rails for good? Let's begin, starting with number 7. Launched in 2020, the Siemens Vectron dual mode cuts a sleek figure across Europe's railways, blending electric and diesel power in a single modular machine. Rated at 2,400 kilowatts for both electric and diesel traction, it can switch between modes on the move, gliding from city terminals to rural freight lines without pause. With an axle load of just 21 metric tons, about 46,300 pounds, it delivers heavy haul capability while minimizing stress on the rails. Operators like Deutsche Bahn and ÖBB found that running these locomotives on mixed electrified routes saves up to 22% in lifecycle costs compared to full electrification, and slashes emissions by hundreds of tons per year. By reducing the need for costly track reinforcement, the Vectron sets a new standard for sustainable heavy traction, proving that even among giants, innovation can mean a lighter touch on the rails. North of the Arctic Circle, the Bombardier IORE stands alone, built not just for power, but for survival in a world of snow and iron. Each twin-unit locomotive weighs in at 360 metric tons, with a staggering axle load of 30 tons, about 66,000 pounds per axle. That kind of pressure demanded more than just a strong engine. The entire Malmbanan, Sweden's iron ore line, had to be rebuilt from the ground up. Rails were thickened, bridges reinforced, and substations upgraded to feed the IORE's appetite for electricity. 10,800 horsepower delivered through icy wind and darkness. Trains stretching nearly a kilometer long, loaded with up to 8,600 tons of ore, thunder through the white wilderness between Kiruna and Narvik. In Kiruna, residents reported windows rattling and ground vibrations so strong that city council minutes recorded complaints tied directly to the passing ore trains. The IORE didn't just challenge the limits of electric traction, it forced a reimagining of what a railway could endure. Even in the age of clean, modern power, the sheer weight of ambition still shakes the earth. In the late 1990s, the GE IC6000CW roared onto American rails, its 6,000 horsepower engine delivering a seismic jolt to the world of heavy freight. Weighing in at 430,000 pounds, with a CC wheel arrangement and an axle load approaching 71,000 pounds, this diesel-electric behemoth was engineered to move mountains, literally. On steep western grades, a single AC6000CW could launch a loaded coal train with 188,000 pounds of starting tractive effort, its traction motors clawing at the rails. But that power came at a price. Union Pacific and CSX field reports from 1999 to 2002 detail a string of track stress incidents, rails kinked by thermal expansion, localized fractures, and even near derailments during peak dynamic loading. Early 7HDL engines, pushed to their limits, suffered reliability woes, forcing maintenance teams into a relentless cycle of repairs and upgrades. Railroads found themselves locked in a trade-off: fewer locomotives per train, but sharply higher spending on track renewal, tie replacement, and ballast stabilization. The AC6000CW didn't just test the rails, it redefined the boundaries of what a single locomotive could demand from steel and stone. On the Pennsylvania Railroad, ambition took the form of the S1 and T1 duplex locomotives, machines built for speed, gleaming with Art Deco lines and chrome. The S1 stretching over 140 feet, and the T1s, with their rigid duplex frames, were designed to break records on the main line. In 1946, engineers pushed the S1 past 101 miles per hour, on the Crestline division, chasing a vision of passenger trains that could rival the fastest in the world. But that velocity came with a hidden cost. Technical bureau memos from the period describe a phenomenon called hammer blow, the pounding force of massive drivers oscillating at speed. During the Crestline test, inspectors found the track alignment warped in multiple places. The rigid frame and 60,000-pound axle loads amplified every vibration, turning dynamic augment into a threat for the rails themselves. Oral histories from the T1 Trust recall crews feeling the rails shift beneath them as the duplex thundered by. Its 6,700 horsepower at 100 miles an hour, straining steel and stone. The Crestline findings forced a reckoning. Innovation had outpaced infrastructure. The S1 and T1, marvels of engineering, revealed the limits not just of steam, but of the tracks meant to carry them. Across the vast railways of China and the former Soviet Union, it wasn't a single locomotive that threatened the rails. It was an army. Over 4,700 QJ steam locomotives rolled out of Datong, each weighing close to 200 tons, their 50,700-pound axle loads pounding the tracks day and night. These weren't isolated giants. They moved in waves. Mile-long coal drags, double-headed freights, endless lines of raw industry. The rails beneath them, once laid at like 43 or 50 kilograms per meter, buckled under the strain. Ministry records from the 1970s document a relentless campaign to replace lighter rails with 60 and even 75 kilograms per meter steel, just to keep up with the punishment. Track workers recall the clang of sledgehammers echoing through midnight as emergency repairs followed another QJ's passage. During the Cultural Revolution, production quotas drove the factories to extremes. 16-hour shifts, skipped safety checks, and slogans plastered over the assembly lines. Accidents and derailments, rarely reported in official tallies, left scars on the network. When the DF4 diesel arrived, 2,940 horsepower, built for bulk, the pressure only intensified. By the 1980s, the entire mainline grid had transformed, rebuilt for the weight of these relentless fleets. In China, the tracks didn't just carry giants, they were reshaped rail by the sheer force of numbers. Deep in Appalachian coal country, the Chesapeake and Ohio H8 Allegheny thundered up the grades, a 7,500 horsepower brute with an axle load that sent shudders through every spike and plate beneath it. Built by Lima between 1941 and 1948, 60 of these monsters rolled out, each one tipping the scales with 70,000 pounds pressing down on every driving axle, heavier than anything the rails had ever endured. Boardroom records from the C&O Historical Society reveal the tension behind closed doors. Chief Engineer William Woodard warned, "You want a locomotive to beat mountains, you'll get a new mountain of track repairs." Yet the promise of moving more coal faster over the Allegheny grades proved irresistible. Maintenance logs from Clifton Forge to Hinton read like battle reports, spike plates sheared, rails bruised, ballast pounded loose after every heavy run. Crews learned to watch their speed on curves. Too much throttle and the risk of derailment soared. The C&O responded with upgrades of their own, heavier rails, reinforced bridges, and more frequent tamping. But the cost debate never faded. Meeting minutes from 1942 lay it bare. We authorize the axle load, but we do so knowing our maintenance crews will have to live with the consequences. The Allegheny's legacy is written in both tonnage records and the scars it left on the Blue Ridge. In the contest between profit and infrastructure, this was the locomotive that forced the railroad to choose and then to pay for power beyond any previous limit. Union Pacific's Big Boy was never just a locomotive, it was an event. At 132 feet 9 inches long and tipping the scales at over 1.2 million pounds, Big Boy dwarfed anything else on the rails. Designed by Alco and delivered between 1941 and 1944, Only 25 of these articulated 4884 giants ever existed, each built to conquer the steepest grades of Sherman Hill without help. Every axle bore nearly 68,000 pounds, pushing the limits of American track engineering. Maintenance logs from the Wyoming division tell the story. Spike plates sheared, ties pumped loose, and rails flexed visibly as Big Boy crawled uphill with 3,600-ton trains. Engineers describe the sensation as standing beside a living force of nature. The rails would thrum like a giant cello, one recalled, feeling every vibration through the cab floor. Dynamometer tests recorded tractive effort peaking at 135,375 pounds, enough to wrench a stalled freight up a mountain. The wheel sets themselves, measured decades later at MEXV Rail, showed stress marks and wear patterns unique to the pounding of Big Boy's mass. On wet days, a slip of a single wheel could send a shudder down the entire line. Track crews braced for the aftermath, bi-weekly inspections, fresh spikes, and sometimes emergency repairs after a heavy run. Even the infrastructure had to adapt. Bridges were rebuilt, coaling towers enlarged, and turntables widened just to accommodate the Big Boy's bulk. Yet for all the strain, these machines delivered reliability, power, and a legacy that endures. When 4014 steamed again in the 21st century, crowds lined the tracks, drawn by the same awe that once made towns tremble as the Big Boy rolled by, a true giant, unmatched in size, load, and legend. From the innovative Siemens Vectron dual mode, designed to lighten the burden on modern rails, to the awe-inspiring Union Pacific Big Boy, whose million-pound weight could make the ground itself tremble, this countdown has traced the relentless pursuit of power in rail history. Across all 7 entries, one pattern stands out. As locomotives grew heavier and more powerful, from diesel electrics like the GEAC 6000 CW to steam legends like the Chesapeake and Ohio H8 Allegheny, the tracks themselves became the final test. Some, like the Soviet and Chinese freight fleets, showed that sheer numbers could strain entire national networks, while others, like the Big Boy, pushed the limits in a single thunderous machine. The most shocking moments came from those titans that forced entire lines to be rebuilt, revealing a constant battle between engineering ambition and the realities of steel and earth. In the end, these train giants remind us that every leap in power carries a price, and the tracks they thundered over still bear the marks of their passing. The race for bigger, faster, and stronger has always shaped the rails beneath our feet.